Imagine a gift, not just any gift, a gift for all humanity. This gift was launched on Christmas Day. The year was 2021. It soared into the blackness of space. This was the James Webb Space Telescope, or JWS for those in the know, a new eye on the cosmos, ready to show us wonders. The world watched with bated breath. Years of planning, years of building. Thousands of brilliant minds worked together. Nations collaborated for this single purpose, to send this marvel far beyond Earth. 1 million miles away, it journeyed to a special place in space, a place where it could see clearly, unfettered by our atmosphere's haze. The launch was just the beginning, the start of an epic voyage. Webb has a grand mission, a truly cosmic quest. It's designed to look back in time, way back, to the universe's early childhood. Imagine seeing the first stars ignite, the first galaxies forming like tiny seeds. This is what Webb aims to do. To witness the cosmic dawn, a time we've only dreamed of seeing. Light, the cosmic messenger, takes time to travel. The light from distant objects has journeyed for billions of years to reach Webb's golden mirror. So, when Webb looks at faraway galaxies, it sees them as they were. Long, long ago. It's like a cosmic time machine, showing us the universe's baby pictures. Webb also studies how galaxies evolve, from those first tiny clumps, to the majestic spirals we see today, like our own Milky Way. Its mission is to expand our understanding. Since it began its work, Webb has been sending back images that are simply breathtaking. They are sharper, deeper, more detailed than anything we've seen before. It's like we were partially blind, and now, suddenly, we can truly see the universe in all its glory, revealed by Webb's powerful gaze, a cosmic art gallery, open to all. These images are not just pretty pictures, though they are incredibly beautiful. They are packed with scientific data. Each pixel tells a story about temperature, composition, distance. Scientists pore over these images like cosmic archaeologists sifting through ruins, finding new objects, new phenomena, things we never knew existed, or things we only theorized about. Think of the famous pillars of creation. Hubble showed them to us, but Webb has shown them anew. With infrared light, it pierces the dust, revealing newborn stars hidden within, stars like fiery diamonds. So how does Webb perform its magic? It's a cosmic detective, you see, equipped with amazing tools. Its primary mirror is huge, over 6.5 meters or 21 feet across, made of 18 hexagonal segments, coated in a thin layer of gold. Gold is excellent at reflecting infrared light, the very light Webb needs to capture, from the distant ancient universe. This light is incredibly faint. Imagine trying to see a single candle from thousands of miles away. That's the kind of challenge Webb faces. So its instruments must be super sensitive and super cold. Heat creates its own infrared glow, which would blind the telescope. So Webb has a giant sun shield, 5 layers, each thinner than a human hair. This sun shield keeps the instruments at a frigid minus 233 degrees Celsius. That's minus 388 degrees Fahrenheit. 2 main cameras help it see. NIRCam, the near-infrared camera. Section 5, Alert in the Darkness. Spotting Asteroid 2024 YR4. Now let's talk about something closer to home. Our own solar system. It's not just planets and moons, it's also full of smaller stuff. Asteroids and comets. Space rocks big and small. Most are harmless, orbiting peacefully. But some come close to Earth. These are called near-Earth objects, or NEOs, and we need to keep an eye on them. In late 2024, astronomers spotted one. A new asteroid, cataloged as 2024 YR4. Initial observations from ground-based telescopes suggested it was a decent size, perhaps between 40 and 90 meters wide, and its path was interesting. It was going to make a close pass near Earth and our Moon. This was predicted for December 2032, a cosmic visitor needing a closer look. When an asteroid's path is uncertain and it might come very close, scientists get to work quickly. They need more data, better data, to refine its orbit, to know its size, to understand what it's made of. This is where Webb sometimes steps in. Even though it's designed for deep space, it can also study objects in our solar system with incredible precision. Section 6. Webb's Keen Sight. A closer look at a space rock. Webb turned its powerful infrared eyes towards this little wanderer, 2024 YR4. Using its NIRCam and MIRI instruments, it peered at the asteroid, gathering precious photons of light. light that held clues to its nature. What it found was fascinating and slightly different from earlier estimates. Science is all about refining our knowledge, getting closer to the truth with new data. Webb's observations showed something important. Asteroid 2024 YR4 was a bit bigger than some initial ground estimates suggested, around 60 meters in diameter. That's about 200 feet across. Imagine a building, 10 or 15 stories tall, tumbling through space. That gives you an idea of its scale. Not a planet killer by any means, but big enough to be taken seriously. The data also revealed its composition. It seemed to be rockier, less like a loose pile of rubble and more like a solid chunk. Webb also found it was cooler than expected, and it was spinning quite fast. Section 7, a cosmic target practice, 2024 YR4 and Our Moon. So Earth is safe from 2024 YR4, that's excellent news of course, but the story doesn't end there. There's another celestial body nearby, our beautiful cratered moon. And it turns out the moon might be in the asteroid's path. Webb's data refined this probability too. The chance of 2024 YR4 hitting the moon in December 2032, the probability actually increased, from an earlier estimate of about 2% to around 3.8% based on Webb's data. Now this is still a small chance. The vastness of space means most things miss, but it's not a zero chance. And if it did hit the moon, well, it wouldn't affect us on Earth. The moon is our loyal protector. It takes hits for us sometimes. Scientists are quite interested in this. A lunar impact would be a unique event. Section 8, more than just one rock. Webb's growing list of wonders. While Asteroid 2024 YR4 got special attention, it's just one example of Webb's versatility. This amazing telescope isn't just for deep space, it's also revolutionizing our view of our own solar system and the objects that roam within it. It's finding new things all the time, things that surprise and delight scientists, expanding our cosmic catalog, filling in the blanks on our celestial map. For instance, Webb has discovered other new asteroids, some located in the main asteroid belt, that vast collection of space rocks orbiting between Mars and Jupiter. Each new discovery helps us understand the distribution and history of these objects, the leftovers from planet formation. It's like finding new pieces of our solar system's puzzle. Webb has also identified some real oddballs, mysterious asteroid-comet hybrids, objects that share characteristics of both. Are they asteroids that are starting to act like comets? Or comets that have lost their icy tails? These transitional objects are fascinating. They hold clues about the early solar system and the volatile materials like water that were delivered to the inner planets, including perhaps to early Earth. And let's not forget the galaxies. Webb continues to capture stunning images of galaxies near and far. In 2024 we saw close-ups of spirals with bright cores and dusty arms, interacting galaxies caught in a cosmic dance like the Penguin and the Egg galaxies. Nebulae, those beautiful clouds of gas and dust where stars are born, painted in vibrant colors. Each image is a masterpiece of nature revealed by Webb's incredible vision. Section 9, the endless frontier. Why scientists keep watching? So why all this excitement? Why can't scientists get enough of Webb? It's because the universe is talking to us through the light captured by this telescope, and it's telling us incredible stories. Stories of birth, death, and transformation on scales that boggle the mind. From the tiniest particles of dust to the largest structures in the cosmos, Webb is our most powerful interpreter yet. The stream of data is relentless. New images, new spectra, new measurements arriving almost constantly. Scientists are working around the clock, analyzing this cosmic treasure trove. Each discovery opens up new questions, leading to new avenues of research. It's a continuous cycle of wonder, of exploration and understanding, pushing the boundaries of human knowledge. Think about what we've learned already. About the early universe, about galaxy evolution, about the birth of stars and planets, about the asteroids in our own backyard, and the potential for life elsewhere. Webb is not just confirming old theories, it's also finding things we never expected, challenging our assumptions, forcing us to think in new ways. That's what good science does. The James Webb Space Telescope is more than a machine. It's an extension of our senses, a testament to human curiosity and ingenuity. It reminds us that we are part of something vast, something ancient, something beautiful, and that there's always more to explore.